Okay, chapter 5 is also another more conceptual chapter without any homework associated with it, but you should understand the concepts behind these. So in making meaningful comparisons, the first section of this gives a brief discussion about the different technical terms. Everyone is usually aware of differences between like mean and median, but when you say average, what do you mean? You usually mean the mean, not the median or the mode. But you should always use those more precise terms just to make sure that everyone is on the same page. We talk a little bit about the percentiles, like percent change and percent point differences. So make sure that whatever you are doing, that you're doing it correctly. And they also give you some lovely basically formulas here for calculating these different common calculations if you need those for your project. So that's nice. Bottom part of this here talks about causal relationships. So most people have heard the saying, correlation does not mean causation. So just because you have a correlation in your data, whether it's a statistically tested correlation or it's just a pretty graph that has, you know, a trend line that looks like, oh, these two things are associated. You want to make sure that you're not implying a causal effect when you're talking about your results. So yeah, so here they talk about common phrases that imply those things: leads to, promotes growth, sparks change. More precisely, you want to talk about like correlation and association. It seems to be a relationship between X and Y, things like that. Yes, these are very scientific ways of saying things. Does your business leader want you to hear about an association between X and Y? No, they want to hear about the causal effects. But you have to be aware that even if you have a statistical correlation between two different things, if other things aren't in place, so one, that there's a time difference between and it's in the correct order, so your cause needs to go before the effect. If you're measuring things at the same time, you can't really make that causal claim, for example. And it has to be designed in a way that lets us make those claims. It's always actually, even the best studies, it's hard to make those causal claims. So yeah, so just be very aware, especially if you are not the one who collected the data in the first place. It can be very, very hard to tell how well people put those parameters in place when they're collecting the data. Even things like, you know, you see that mask use decreases the amount of cases and such. Is it causal? Probably. But like, you know, vaccines hit and the caseloads go down. Probably. But it's not until you actually look at the real studies that you can go, okay, yeah, like we know that these people actually had the vaccines and yada, 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 right? So yeah, so just make sure that when you're getting random data that you're not claiming things that aren't there. The second part of this is talking about normalization. So pretty sure the data mining class talks about this fairly well, which is good. So if you have done normalization in different platforms, feel free to use whatever platforms you want for all of your data cleaning needs, whether it's G Sheets or R, or I think the data class is the mining class is using Orange. That's one of the programs I used in there anyways. But yeah, whatever you want to use for this stuff is totally fine. So with the normalization, there's two main points for this is checking the scale. This is especially important when you're working with time or multiple data sets. What do I mean by that? The way things are measured often change over time. We had the example earlier about race. They were talking about how if you look at the words that they've used over time and how people are classified in different groups, those have changed significantly. And so if you're trying to compare racial groups, like depending on what time frames you're talking about, you can be talking about totally different populations. Asperger's and autism is another really good one. If in the psychology field anyways, we've gotten away from using the term Asperger's. And so if you're looking at older studies that talk about autism, those folks are not included in it. And then when the DSM-5 was released and all the doctors start reclassifying people, then you have a different set of people that are in the same group. So if you're comparing older studies with newer studies, you're not talking about the same population. So you have to be really aware of the context for the data if it's over time, because those can change a lot. If you're working with multiple data sets, especially from multiple sources, scales can also change because of that. Though that can be a simple matter of, even if like employee engagement study, same company, but 1 year they are using a 5-point scale and 1 year they're using a 7-point scale. Those two different scales mean that you're gonna have to do some math to normalize them. Yeah, sometimes they're asking the questions in different ways, in which case you can't even really normalize them because they're asking different questions. So again, that's a little bit more on the context side, but it happens a lot with multiple data sets as well, especially if you're looking at different companies, combining different data sets from different companies and things like that. Real life example of that, and I'm sorry, I didn't think I'd be using COVID so much, but it's on the brain. It's great for data. But when you're looking at the hospitalizations and the different diagnoses for severity for COVID, when they first started trying to collect the data from across the world, every country had their own way of saying like, oh, this is severe and this is mild. And though because those lines were different between them, when you're trying to compare the data across the world, your data ends up just being messy. It's not accurate at all. And so you can't really draw an accurate picture when you're not using the same scale. Okay, so that's normalization. How do you actually normalize? It kind of depends on what is going on in here. And I do hope that you do read the reading in here instead of just listening to me ramble on about it. Because here they're talking about different ways of normalizing and different considerations here about adjusting for population, adjusting for mileage, all sorts of different things. Yeah, so there's that. Some tools will kind of do this stuff automatically for you. Otherwise, it's a little bit more of using math. For example, with the 5-point and the 7-point scale, what does 5 and 7 have in common? 35. So if you multiply the 5 by 7 and the 7 by 5, you've got the same base fraction denominator of 35. So you can now compare the two if you multiply both columns like that. So how you normalize depends a lot on what you're trying to normalize. The z-scores that they mentioned in here is what I'm used to in the stats world. Yeah, so if you need to normalize your data for the project and you don't know how to, then we can chat and I can try to provide you some guidance on that. there's just too much going on and too many platforms and stuff for you to be able to try to figure that out just from this by itself. The last thing that's talking about here is bias comparisons. Talks about selection bias and non-response bias, self-selection bias. These can be more simply asked. The big question is, how is your data collected? Was it a random sample? Usually not. Even things that are randomly sampled aren't usually fully random. And I don't mean in the sense that computers always have a starting seed and so nothing is actually random. It's more about, like, for example, if you think that if you call, if you have a directory of every phone number in the entire US, and you're going to randomly call 100 people, there's a lot of people that don't have phones or don't have listed numbers, right? So those people are automatically not in your list. And no matter what you're thinking about in terms of selecting people, there's usually people that aren't on your list unless it's something like a company directory, right? A very small population that you're sampling from. So the question, so that's a data collection issue that feeds into, is the sample representative of the entire population? Non-response bias. So are people allowed to not respond? Usually the answer is yes, but not always. Company example, our employee engagement survey. At our company, we have like amazing numbers. We've got a 97% response rate. Usually it's closer to 50% response rate because we bribe people with pizza and ice cream. Do they always give good data? No, sometimes they just click through, but you have a pretty good response rate. A lot of times senior leaders will skip surveys because they're really, really busy. If your meeting is meetings, if your day is meetings all day, you don't want to take 30 minutes to do a survey. Even a 5-minute survey seems like a lot when you're, facing 100, 200, 400 emails a day. Is there self-selection bias? So this survey here, super duper biased, right? So the only people answering the survey are people that happen to be reading this book of all the possible DataViz books. So they're probably either people that are on a budget trying to access a free resource, or they just, happen to get this handed to them as this is a good resource one to do. They are people that understand English unless they're being translated from something else. It's a web page, maybe Google Translate or something can work, but they're probably mostly English speakers. They're people that have access to a computer and the internet. People that are interested in DataViz is probably the population that you want. But yeah, all these different little considerations of who's actually taking this survey. And I am reading this book. I am interested in DataViz. I did not fill out the survey. I don't know if you did. Probably at this point you probably didn't, but by the time your data is, or by the time you're watching through this and stuff, maybe you did, maybe you didn't. You self-selected whether you're going to participate or not, right? So who are the types of people that are likely to answer a survey like this will also feed into that self-selection bias. And it's hard for us to predict who will answer a survey. So we can guess, but we really don't know all the factors that lead into that and not. So things to think about when you're looking at survey data, and the overall picture of that being, is this sample actually representative of the population?